according to this computer. There we go. Okay. So what is a differential equation? A differential equation is one that involves a derivative. Also, the order is considered the order of the highest derivative involved in the equation. Now, there is a college class called Solving Differential Equations. It's a pretty advanced class that you probably do in college if you decide to do a STEM major, or econ. Econ, I believe they cover that class also, if I'm not mistaken. So let's see. So we're only going to obviously work with first derivatives. So we're only going to do first order. And I would actually have to personally brush off my textbooks to learn how to do the second and third. I forgot to do those. For this class, we only do first order. So you have dy dx equals this. So we call that a first order differential equation. And for short, I'll call it diff eq. This is called a second order because you have a second derivative. But for this class, we'll only do first order, so we'll keep things simple. So here you ask to find the general solution to this equation. So what we do is you do something called separating the differentials. That's one way you can kind of go about this. So you can multiply both sides by dx if you so desire. And we'll just talk more about this also next week. Oh, +2. And you have dx right there. Then integrate both sides. So you end up getting y equals, now the antiderivative cosine is negative sine x. Sorry, sine x. The antiderivative sine is negative cosine, so it's plus cosine x. And then plus 2x. And then plus c. And that's all. That's all you would do. And if you took the derivative of this, you would get back to cosine x minus sine x plus 2, if you did take the derivative of that. Or here's another one. You have this right here. So you could, again, multiply both sides by dx. And you can write that as 2x in -1 minus 6x in -3 dx. The reason why we have this part right here will be a little more clear in the video, so don't worry about that for now. Watch the video homework lesson on that, why we have to have that, but don't worry about it for now. Remember I mentioned that you want to add 1 to the exponent, divide by the new exponent. The problem for this one, if you add 1 to this exponent, you're dividing by 0. So that's kind of a problem. But hopefully you recognize the fact that if you have 1 over x, so actually I probably should not have done x -1. If you have 1 over x, that's going to be natural log of x. That's because derivative natural log of x is 1 over x. We talked about that fall semester. And then here, if I add 1 to the exponent and divide by a new exponent, and then plus c. And the other reason why you need to say that to x greater than 0 is that you can't log negative numbers. So I think that's another reason why we have that there. But there's yet another reason why we do that, and that's explained in the video lesson for homework. And that'll be plus 3 over x squared plus c. So that's your answer to that differential equation right there. So we call them general solutions because you don't know what c is. We will, in the video, we'll talk about when c, how to solve for c. Be very careful though, when you take an antiderivative of a product of two functions. So in this case, there's no really such thing as a product rule for antiderivatives. There's something called U substitution, which I'm going to talk with you guys on Friday. But yeah, you can't just do that. Like, that's bad. Because if you, it's really bad. Because if you took the derivative of this, then you would get this. You got to do the product rule here then. I took a derivative of that, it'd be x6 times cos x plus 6x5 times sine x, which should not get us back to this right here. So you got to be mindful about that. But this one here, if you can kind of see what's going on for this one, it's kind of like there's a chain rule happening here. So you're, if you think about it, the derivative of 7x squared is 14x. So you could just say y equals e7x squared plus c. The reason why is because if you took the derivative of this, you do e to whatever, but then you got to do your chain rule times 14x and then plus 0. So sometimes you have to use just a little bit of intuition. And this will be the last example I'll do, and we'll end it right there for today. Then we'll pick this up again on Thursday. Find the general solution to this diffie-q. So, and we don't, I mean, you know, I like multiplying both sides by dx. We don't really need to do that every time, but dy equals 2 radical 1 minus x squared plus 3x squared cosecant squared x cubed. If you do all that, then this would be 2 inverse sine of x. Hope you recognize that. This would be, remember the derivative of cosecant squared, I think was, oh sorry, derivative cotan, got cosecant squared, but it's negative, so it should be minus cotangent of x cubed. Because if you took a derivative cotangent, it would be negative cosecant squared, but you got to do a chain rule as well. And then plus c. And you can always check by taking a derivative of that and getting back to the answer. So what I would suggest that you guys do when you're doing these problems is go back to the derivative cheat sheet that we had a while ago, which I actually have on the front page in our Schoology page. And take a look at these here. Like you can see that if you have negative cosecant squared, then the antiderivative would be cotangent. Or the antiderivative of cosecant squared x would be negative cotangent. So you're just going backwards from these. So use these to help you. Or 1 over root 1 minus x squared, the antiderivative of that is inverse sine of x, because the inverse sine was that. Because now we know these are interchangeable now that we've talked about fundamental theorem of calculus. Or the antiderivative of 1 over x is natural log of x. The 3x squared is actually taken care of. Someone's asking about it. It's actually taken care of because if you do the derivative of cotangent x cubed as a check, so if we check our work, the derivative of inverse sine is 1 over root 1 minus x squared, so you get that. The derivative of cotangent is negative cosecant squared, so you have negative of negative cosecant squared of x cubed. And you got to do a chain rule, so you got to multiply x cubed with 3x squared, so 3x squared comes back when you're doing the chain rule. And of course, derivative of c is 0, so you ignore that. So we'll end it there for today. We're a little bit over time. Hopefully, you guys will feel okay doing the textbook problems. I'll remove the worksheet. I think it's just repeating our efforts. I don't think it's really, because I'm asking you to do definite integrals anyway on the textbook. So no need to do the worksheet. I think that was kind of pointless. But homework will involve a little bit of 7.1, but mainly 6.4. There'll be a video that does a little more on 7.2, so we'll pick it up, sorry, on 7.1. So we'll pick it up again next time we meet. And I think that is it. Okay, I do have another meeting to hop into, so have a great lunch. If you want to get ahead of homework, homework's all set now. So, but I'll let me update and remove worksheet 7B. You don't need to do that anymore.